The game of soccer is one of the most popular team sports worldwide. Soccer kick is the main offensive action during the game. Good kicking technique is an important aspect of a soccer player. Therefore, understanding the biomechanics of soccer kicking is particularly important for guiding and monitoring the training process and prevent the players from suffer an injury. Soccer kick is characterized by a proximal to distal motion of the lower limb segments of the kicking leg. Angular velocity is maximized first by the thigh, then by the shank, and finally by the foot. This is accomplished by segmental and joint movements in multiple planes. Kicking from a biomechanical perspective can be separated into components in various ways. The first is the approach angle. This is commonly used as it orientates the body to gain greater hip and knee flexion range of motion. Efficient segmental timing for the kick reveals that maximum angular velocity at the knee progressively increases with age during the pre-adolescent years. Another component of the process is the planned foot forces. When in step kicking for maximal effort, force that is generated from the approach path and planned foot positions can and does influence the channeling of forces that eventually are used into propelling the ball. Flexion at the hip and extension at the knee are also involved, as the hip flexors forcefully contract to swing the thigh forward and downward. As tight angular velocity decreases, the leg and foot begin to accelerate due to a momentum shift and support from elastic and contractile components in the knee extensors.
The purpose of this project is analyze the football kicking work on age subjects and observe the difference within women and men applying the principle of biomechanics. First, we select 8 people to record a video of them kicking a soccer ball. Our subjects were 4 females and 4 males. The videos were recorded from a distance between 2 or 4 meters away to secure the view of the joints of hip, knee, and ankle. To analyze the movements of each person kick, we start by using the software RichMess to obtain data related with the coordinates at the certain moment. We choose our frame to start working on there. This is used to identify the joints movement during the time that we select. Also, we use a software called Kinobea. This one helped us to obtain the angles that were produced by the leg at the same moment we took before. Then we start with our calculus of the time, position, velocity, and acceleration linear and angular data. With the time and position calculated from the frames and coordinates before, we were able to also calculate the linear velocity in the x-axis and in the y-axis in hip, knee, and ankle for each subject. The graphic shows us how the linear velocity of the hip in the x-axis that the most of the subject had a decrease in the velocity from the beginning until the second 0.50 approximately. In the knee linear velocity, the graphics tell us that our 8 subject had a constant velocity in the x-axis, while in y-axis had little variations. This might be justified because at the moment of kicking the ball, our velocity is reduced by the opposite reaction applied by the ball. Analyzing the ankle linear velocity, we can notice how the velocity in y-axis has now the constant velocity, while all of our subjects present many variation on their velocity in the x-axis. Analyzing the data from graphic, from a first view, we can say that all of acceleration were constant. The graphics of the heap, we notice how present a deceleration during the first seconds, and from there, it remains constant during the rest of the movement. For nonlinear acceleration in the x-axis, we notice how not even in the first second have variations. It had an acceleration constant, and in the y-axis present a pattern just like the ones we saw in the heap accelerations. In the uncollinear acceleration, each subject starts with a different acceleration, and some of them, mostly meant, present an acceleration in x-axis, while in y-axis, all subjects it remains constant. This means how many degrees or radians an object, in this case our joints, has traveled in a certain time. In the graphics from the heap, all the subjects present different movements of the time of kicking the ball. One of them made their upper body to the front, and some of them took their body trunk to the back. The knee angular velocities show in the first second how females had an increase and then a decrease in their angular velocity, while males had the opposite. Analyzing the ankle, most of the line follow the same pattern. This means even they could have a different movements and each of them made the kick as they wanted, the ankle remained placed similar in the each kick. The graphics represent the angular acceleration in the same joints from our 8 subjects. The heap represents many variations between each subject. This means each of them worked their ankles in different ways, in making more change in their velocities as we saw before. And the knee and ankle have a similar pattern. Also, the moments were calculated. The moment of force depends on the perpendicular displacement from the line of the action of the force and the axis of rotation. In this case, the heap was the center of rotation. We also calculate the force exerted by each person in each joint, and finally the total of the force that was applied on the ball. We discussed that after kicking the ball, we saw an increase in the angles in comparison with the angles before the action. We thought that angles will be higher in women than men. This is because women usually have more flexibility, but the values of the angles varied without the pattern. This depends more on the technique that people used. In conclusion, the research of kick biomechanics should identify the appropriate mechanism leading to a powerful and accurate in-step kick. Research is required to identify soccer kick biomechanics during a specific game condition and to prepare useful information for the soccer player and the coach.